Okay, question 7, June 15th, 2011. This is chapter 7, question 7. Two office towers are 50 meters apart. From a window in the shorter tower, the angle of elevation to the top of the tower is 41 degrees. From the same window, the angle of depression to the base of the other tower is 34. Find the height of the taller tower. Be sure to include a diagram. So we're going to draw a diagram. We're going to draw our two buildings. So building 1, building 2. We know the buildings are 50 meters apart. There's a straight line function for that, you know. Okay, so we have the angle of elevation and depression from the one apartment building. We know the straight line distance across is 50 meters. The angle of elevation, which is the top angle there, is 41 degrees. And the angle of depression is 39 degrees. Oh, sorry, 34. 34 degrees. Now what we're going to do is we're going to solve the other sides of both right-angled triangles and then add them together to figure out the height of this building. So we'll do the top triangle, 41 degrees and 50 meters. Get the magic pen. With that angle, 41, we have the adjacent side, so point to the adjacent side measurement. No, angle 41. Get an arrow to 50. All right, so that's the adjacent side, and we're trying to solve for the opposite side over there. We're going to call that side X. So write in X with the permanent one. Okay? So, because we have an adjacent and opposite, we're going to use tangent. So we're going to use tan 41 is equal to the opposite, which is X. So put in X divided by 50. Now when we move 50 to the other side of the equation becomes 50 times tangent 41. So wait, bracket 50, or, okay, bracket tangent 41 times bracket 50 is equal to X. Okay, push button. Can, doesn't matter. Okay, so we're going to put tan 41 equals, and then we're going to multiply that number. So multiply by, we'll do it all one step, 50 equals. So the height from the middle or the opposite balcony upwards is 43.4 meters. Okay, 43.4 is equal to X. Now we're going to set up the same thing. Can you scroll over a little to your left? We're going to set up the same thing with the bottom triangle. Again, we have the adjacent side. It's okay. The adjacent side is 50 meters, and we're looking for the opposite side. We're going to call that Y. Okay? So we're going to set the same equation, or same type equation up, because we have an opposite and adjacent. Can you push pause, Anthony? So we're going to set this up, again, because we have opposite and adjacent, we're going to use tangent 34 is equal to the opposite, which is Y, and the adjacent side is 50. When we bring 50 over, we have tangent 34 multiplied by 50 is equal to Y, and Y will be equal to, we're going to type this in the calculator, tangent 34 is equal to times 50. 33.7. So Y is equal to 33.7. Now, to find the actual height of the building, we have to make another equation. X plus Y will be the height of the building. So X plus Y equals, we'll say H, or height of the building. Great. We're going to substitute in 43.3, or 0.4, plus 33.7 is equal to, and we'll put that in our calculator. It's going to be 77.1. 77.1. You won't be able to. Okay, question 8 says, after climbing all the way to the top of the CN Tower, Beth sees a car on one of Toronto's streets that is 346 meters away from the base of the tower. From reading the information pamphlet on the CN Tower, Beth knows that the CN Tower's height is 533 meters. What is the angle of depression from Beth to the car? Round your answers to the nearest whole number. Include a well-labeled diagram as part of your solution. So we have our CN Tower from where she's looking out of, and from the base of the CN Tower to a car. So we put a car at the other point. Okay.
Why is the base not flat at all?
It's a little misdrawn, but it's okay. We're going to assume the ground is on a slant. But, all right, we're still creating a right angle here, okay? So we know from the base of the tower to the car is 346 meters. And we know the height of the CN Tower is 533 meters. Okay? Now, we're trying to find the angle of depression. But the angle of depression is technically in an opposite triangle right now. So I can either solve for the angle at the top of the CN Tower or the angle beside the car. Because the angle beside the car, put an angle there, right where you are. That angle there, and then go to the angle of elevation, do it in a different color. Alternate angles. These are alternate angles, these two? No, that one, yeah. So the angle by the car and the angle of depression are alternate angles. So if we solve for the angle of the car, we'll actually get the exact same angle as the angle of depression. Okay, so since that angle by the car, we have the adjacent, which is 364, and the opposite, which is 533. We're going to use tangent theta. So tan theta is equal to opposite, which is 533, divided by 346. 346, okay? So we're going to divide those two numbers in our calculator.
No, I did so many.
We divided it, we get 1.54. So tan theta is equal to 1.54. And now to isolate for tangent, to isolate for theta, we need to move tangent to the other side. When we do that, it becomes the inverse tan. So tangent to the power of -1, and then we plug in 1.54 into that equation. So we put second function tan, 1.54 equals 57 degrees. So the angle of depression, actually the angle beside the car is 57, and since the angle of depression is an alternate angle to that, the angle of depression from that top of the CN Tower there is also 57. Okay. Good. Do you have your picture? Okay, question 9. A communication tower is fixed to the top of a building. From a point that is 10 meters from the base of the building, the angle of elevation to the top is 60. And to the top of the tower is 68. What is the height of the communication tower to the nearest tenth of a meter? Include a diagram for communication marks. So we have our building and our tower. The angle, we also are going from a spot that is 10 meters away. So take that to the bottom, draw the base. There we go. So we know that is 10 meters away. So put in the 10 meters. Now imagine the building is standing up straight. Okay. We know the angle of elevation from the point 10 meters away from the building to the top of the building is 60. The bottom part, a smaller triangle. Yep. That's 60 degrees. And we know that the angle to the top of the tower is 68 degrees. 68 is from the top of the tower right to the ground, not just the little part. You're not sure erase it.
Come on, man.
Okay, so with this means is we have information to find the height of the building. We have information to find the height of the building plus the tower. But we don't have enough to, in one step, solve for the height of the tower. So we're going to have to solve for the two and then subtract them to figure out the height of the tower. So we will solve the height of the building first. So we have the angle to the top of the building is 60 degrees. The adjacent side is 10 meters. And we're going to solve for the opposite side, which is the height of the building. We'll call that x. Okay? So tangent 60 is equal to the opposite, which is x, divided by 10. We need to move the 10 to the other side of the equation, so it becomes 10 times tangent 60 is equal to x. We're going to put in our calculator. Tangent 60, nope, clear that. Tangent 60, put that first, times 10. You have to do tangent 60 first. 17.32. So the height of the building is 17.32 meters tall. Now, the other part we're going to solve is from the top of the tower to the bottom of the building. Do that in a different color. Okay. So take a line from the top of the tower to all the way down. Okay. We're going to call that y. Okay. So our angle from our point 10 meters away is 68. So we're going to do tangent 68. Yep. Is equal to y divided by 10. Exact same idea. Let's bring the 10 to the other side of the equation. We're going to do tangent 68 is equal to, and then times 10. So the height of the tower plus the building is 24.75 meters. Now, in order to find the height of the tower is equal to y minus x. Okay, so we'll make our third equation. Y minus x is equal to height of the tower. So our y is 24.75. Subtract 17.32 is equal to 7.24, is it? Oh no, 33. 43. That's it. 7.43. So the height of the tower is 7.43 meters tall. Okay, question 10 gives us two triangles. They're both right-angle triangles, and it wants us to solve from the distance from point D to point C. They're both right-angle. What we're going to be doing is we're going to be using this one. Okay, so we're going to be using Pythagorean theorem to solve for the distance of A to D and A to C. So our first triangle, we'll call it A10, and we're going to call C14 squared, okay? 10 squared is 100 plus B squared is equal to, look at the calculator, 196. Okay. We bring 100 to the other side of the equation. It becomes 196. Subtract 100. B squared is equal to 96. We find the square root of both. And B is equal to
9.798.
Okay. So what that is I want you to write that is the distance from A to D. So put a little note there. Yeah, do it in blue. From A to D is 9.79, we'll say. Now the next thing we're going to solve is the distance from A to C. And we're doing Pythagorean theorem again, same idea. A squared plus B squared equals C squared. A can be our 10. This time C is 16 because the hypotenuse is longer on a different triangle. 16 squared. 10 squared is 100 plus B squared is equal to 256. We bring 100 to the other side of the equation. It becomes 256, subtract 100. B squared is equal to 156. We're going to find the square root of both sides. So the square root of 156 is equal to 12.49. So the distance from A to C is 12.49. But in order to solve X, that's from A to C. So make a hoop going from A to C for that. Yeah, there you go. It's 12.49. So we now know that X is equal to 12.49 subtracted by 9.798. So 12.49 subtract 9. Blah, 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 is equal to X. X equals 2.69. So our distance of X is 2.69. Okay, 11A. It says that, leave it there. Triangle ABC, so we're going to label this triangle ABC. We've already labeled it different. Okay? It doesn't matter how you label ABC, just as long as your numbers end up being consistent. We're going to call it ABC. Angle A is 90. Angle B is 30. And side B is 10. Side B is opposite of angle B. Now, they asked us to find the hypotenuse in this question. The hypotenuse is from C to B, whether it's opposite of the 90 degrees. So we need to find this hypotenuse. Okay? We have angle 30 degrees. So we're going to use, angle 30 degrees. The side we have is opposite of that angle. And we're looking for the hypotenuse. So if we're using opposite and hypotenuse, we're using sine. Sine 30 is equal to opposite, which is 10, divided by A, which we're looking for, which is our hypotenuse. Now, there's many steps to this one. One quick step could be to just switch the positions of A and sine 30. If we put it to A is equal to 10 divided by sine 30, we switch their two spots, divided by sine 30. Okay? Sine 30 is 0.5. A divided by 10 divided by 0.5 is 20. So the measurement of the hypotenuse of this triangle is 20 centimeters. Triangle PQR. They're giving us a measurement that angle R is 90. Side Q is 17.5. I think I have a plus here. 17.5. And side R is 21.4. The question asks us to find the hypotenuse. If you label a triangle correctly, you've noticed that they've already given us the hypotenuse. Hypotenuse is always opposite of 90 degrees. So the length of the hypotenuse is 21.4. That's why our question was only worth 1 mark.